All right, guys, it's good to see you. And here we are talking about perimeters and areas of similar figures. Okay, so there's a really important concept in this one, and it is understanding that when you hear the word area, you have to think units squared. Now, why is this important? Well, this is important because the perimeter is just in inches or feet or miles. Area is always in inches, feet, or miles squared. So, when you're doing similarities, similarities are nothing more than ratios. And when you're doing a similarity of perimeter, it's just in inches to inches. But when you're doing a similarity of area, everything has to be squared. Okay? So, let's look at a really simple one. Let's say we have two shapes and they're both trapezoids. Okay? And obviously, one trapezoid is bigger than the other. But if I asked you for their ratio, well, that means I'm comparing the two sides. Now, most of you can see that we're in high school, and every time we write a comparison or fraction, we have to remember to do what to it? Correct, reduce it. So in actuality, this is 2/3. So the ratio of the small one to the large one is 2/3. If I'm looking for the scale factor, it would be 3/2. Now, hopefully you remember it's because if I'm getting bigger, the bigger number goes on top. I'm pretty sure you remember that. But that's the difference in the verbiage, the language. If I ask for a ratio of the small to large, then I'm writing the small first, then the large. If I ask for a scale factor from the small to the large, that's the difference, the word. The numbers are going to be the same. It's just scale factor tells me, am I getting bigger or smaller? If I'm getting bigger, then the bigger number would go on top and the smaller number goes on the bottom. All right, so that's the difference between scale factor and similarity ratio. Notice they're the same numbers, just one's flipped. All right, so here I am and I'm just doing a ratio of 2 to 3. Their area ratio would be in units that are squared. So what do I have to do with those numbers? I have to square them, right? The area ratio would be 4 to 9. So my area ratio is always squared. And this would be my perimeter ratio. All right, so looks like let's look at another one. Let's say someone gave me they gave me the similarity factor, or I'm looking at it and it's two pictures, right? And in this picture, we're going to use the same trapezoids, except, well, we'll use a different shape. We'll use a square. This one's 4, and this one's 10. And then they give me one of the areas, okay? They give me the area of the smaller triangle, or a smaller square. They say it's 36 inches squared. Okay. And then they ask me for the area of the bigger figure. Okay, here's the catch, guys. Here you have a perimeter ratio, or a similarity ratio. This would be a comparison of two sides, okay? And we know it would be 4 over 10. We would have to reduce it. It's 2/5. All right. Will this perimeter ratio help me with an area problem? No. To do an area problem, you have to have an area ratio. So that means I have to change this to an area ratio. This is all in the words, guys. So when you look at it, you go, well, how do I know to make it a perimeter ratio, or how do I make it an area ratio? If you need an area, you need an area ratio. If you need a perimeter, you need a perimeter ratio. So here's the area of the smaller one. I need the area of the larger one. The problem is I need to change this to an area ratio. Many of you have already done that. It would be 4/25. Okay? Notice, this is for the smaller shape. So I would put the area that I was given in the smaller shape. And this would be what I'm missing. Then who wants to tell me how we would solve these? Now this should be old school. What is this called? Correct, a proportion. How would I solve it? Cross multiplying. 4x equals let me get this right. 25 times 36. Sorry. Equals 900. Right? Then I divide. So, the area of the bigger shape is 225 inches squared. All right, so this is all proportion work. This is all understanding ratios, whether it be an area ratio or a perimeter ratio. How do I know which one I need? I need the one that I need to use to find. Okay, so if I'm looking for a perimeter, I'm going to need a perimeter ratio. They're going to give them to you back and forth. Sometimes they'll give you the area ratio and ask you to find the perimeter. That would mean you'd have to square root. Okay, forwards and backwards. So let's look at another problem. And let's say it's two triangles. And they give you the area of both those triangles. This one's 50. This one's 98. So they gave me the area of both those triangles. So I'm going to write an area ratio. Right. 50 over 98. That is an area ratio because I'm comparing the two areas. I still need to do what with this? Reduce it. Now notice, this is an area ratio. Now, the question is asked, what would be the ratio of the perimeters? Hopefully you know this is an area ratio, which means everything here is squared. So how do I find perimeter? I'd have to do the opposite of squaring, which is square rooting. And you would see that the perimeter ratio is 5/7. Why? Because I have to square root it. All right? So understanding how to take a perimeter ratio, make it an area ratio, how to get areas, make them into an area ratio, and then square root them and make a perimeter. Why do I need to do this? Because many times they're going to give you one and ask you for the other. You have to be able to work forwards and backwards. All right, so right now, I'll give you the got it problems. There's got it problem 1. Pause your video. Do the problem. Here's got it problem 2. Pause your video. Do the problem. Here's got it problem number 3. Pause the video. Do the problem. And got it problem number 4. Pause the video. Do the problem. All right, the next thing you'll have is the answers. I will go ahead and make sure I take a picture of those and display those answers. And I will go through those questions tomorrow in class. Those got it questions I will go through, as well as we'll have a worksheet to work on. All righty. Thank you very much and have a good night. Bye, guys.